Hello friends, here in this video we will see what is meant by Soderberg's criteria or Soderberg's line. Now here is the diagram. First I'll write down that Soderberg's criteria is used when yield stress is considered for designing. That is Soderberg line. It considers yield stress and it is a graph between variable stress sigma v versus the mean stress sigma m. Now if I can explain the graph, here on y-axis we have variable stress sigma v, on x-axis we have mean stress sigma m. This on y-axis we have the highest point A at which the stress is sigma E, called as the endurance stress. Next on x-axis we have maximum distance at point B, and here the value of stress is sigma y, called as yield stress. So joining A to B will give us a line called as Soderberg line, or it is also called as failure stress line. Next we will reduce this value of sigma E by dividing it with FOS, factor of safety, because factor of safety is more than 1. So sigma E divided by factor of safety, this sigma E point A will shift to point C. Similarly sigma Y we will divide it by factor of safety and point B will shift towards point D, because sigma Y upon Fs, this value is less as compared to sigma Y because factor of safety is greater than 1. So parallel to AB we will draw a line joining CD, and on that line CD we will take a midpoint called P, which is the design point. Next, this horizontal distance of the point P is called as sigma m or mean stress. Vertical distance of this point P is called as variable stress. Next, ORPQ, we can say here there is a square formed. Now once we have understood this diagram, next I can explain this in one more manner, that from the similarity of triangles, therefore from the similarity of triangles, now here I will consider two triangles. First of all, triangle COD, the bigger triangle COD, and triangle PQD, triangle PQD. Now in that I can write down PQ upon CO or OC, PQ upon OC will be equal to QD upon OD, QD upon OD. Next, QD, it can be written as OD minus OQ, OD minus OQ upon OD. So therefore PQ upon OC will become, here we have OD upon OD minus OQ upon OD. Next, OD and OD will get cancelled, so we have 1 here. Therefore PQ upon OC is equal to 1 minus OQ upon OD. Now therefore if we look into the diagram, PQ is equal to sigma V, variable stress. So instead of PQ we have sigma V. OC is sigma E upon Fs, sigma E upon factor of safety is equal to 1 minus OQ. OQ is nothing but sigma m, and OD is sigma y upon factor of safety, sigma y upon factor of safety. Next I will keep sigma V on one side, multiply this term onto the other side. So we have sigma V on one side, and here on multiplication we have sigma E upon FOS. This gets multiplied. Here this bracket will be written as it is. So therefore sigma V will remain as it is. Here we have sigma E upon FOS, 1 minus, here we have sigma m, FOS gets multiplied above, and here we have sigma y. Therefore sigma V will be equal to, on simplifying this we have sigma y minus sigma m FOS, that is the cross multiplication, upon sigma y. So therefore sigma E upon FOS, here this can be written as sigma y upon sigma y minus sigma m upon sigma y FOS. So sigma y and sigma y will get cancelled out. We have 1 here. So therefore sigma v will be equal to sigma E upon FOS to 1 minus sigma m upon sigma y FOS. Next I'll take FOS common from here. So we have sigma E upon FOS into FOS. Now here I am taking FOS outside the bracket. So here we have 1. So it will be 1 divided by FOS. And here we have sigma m upon sigma y will remain as it is. So FOS and FOS will get cancelled out. So therefore sigma v is equal to sigma E 1 upon FOS minus sigma m upon sigma y. Therefore on simplification sigma E will be here. We have 1 upon FOS minus sigma m upon sigma y. So therefore 1 upon FOS will become sigma v upon sigma E as it is. This term sent onto the other side becomes positive. So here I can say that this is the equation of Soderberg's criteria neglecting stress concentration factor. So here we have derived the equation of Soderberg in which there is no stress concentration factor. After this I'll write the equation considering the stress concentration factor. So therefore 1 upon factor of safety is equal to sigma m upon sigma y plus sigma v into k suffix f upon sigma e into k surface into k sz, which is k size. Now here I can say that this is equation of Soderberg's criteria considering stress concentration factor. And here I can write all the terms where k suffix f is equal to fatigue factor for stress concentration, k surface is equal to surface finish factor, and KSZ is equal to size factor. So this is the Soderberg equation considering all the factors, and in this video we have seen what is meant by Soderberg's criteria, Soderberg's line, and how we have derived the formula.